Atlassian study, engineers only spent 16% of their day doing actual coding, right? So we're really optimized at the moment for that 16% where we're filling IDEs with characters. And that was never the job of engineering. I think a lot of organizations are stuck in the conversation around which model they're using, which is a very, 2025 discussion. 2026 discussion needs to be around, how are we empowering people with better harnesses and empowering the whole org with the meta harness that we build. Just like a human needs to have some framework around what it's building. This is what spec-driven development obviously gives it. And so, some people see spec-driven development as just the PRD, where it's a definition of various pieces, and I find that a little bit loose nowadays. QA is, I think, the biggest sort of unsolved problem at the moment in the SDLC, Agentic SDLC, and I think it's a problem in two ways. One is we've always talked about QA shifting left. And the faster we move with agentic development, the less likely we are to actually shift the QA left. A lot of companies, their appetite is going to be to jump straight into building solutions, rather than first of all wrestling with some of the ethical and some of the and some of the regulatory things that they really need to cover off first. And what they'll find is that'll become just a massive break, like a massive breaker pump for them, unless they sort that out first.
Hello and welcome to the Enterprise Tech Talk podcast. I am your host, Saumitra Kalikar. Now, AI has moved rapidly from just being a curiosity to an enterprise priority. Many organizations are now actively exploring assisted software delivery and agentic workflows. Organizations are now discovering that the building flashy AI prototypes is vastly different than engineering secure, reliable, and cost-effective AI systems. And that is why today's conversation focuses on AI engineering. It's not only about prompt engineering or selection of new models, but the broader discipline about how to build reliable AI systems in production. And to help me unpack this topic, I'm joined today by Adam Witanowski. Adam has a wealth of experience at the intersection of AI, software delivery, and enterprise technologies. And with his insights, today we will explore how to move from a prototype hype to a production reality. Adam, welcome to the podcast. Great to have you here.
Yeah, great to be here. Thanks for having me.
Adam, before we get into details, tell us a little bit about your professional background and how you got into AI engineering in the first place.
Sure. I've been in software for about 30 years. So I've been a builder. I've run my own companies, done startups, and predominantly around that sort of startup and consulting kind of space. NIB is where I was at last as a AI architect, and prior to that, I was in the same organization as the senior engineering manager, working with a relatively large team in the travel insurance domain. Moved across into the group domain for AI architect. Obviously, when AI started, it sort of entered the common man's world through ChatGPT, 4 or 5 years ago. This little chat box it just seems like such a simple and almost pathetic way to interface with a profound technology. And yeah, this is what we've landed on. And sort of entered into the world, and immediately I think like everyone was just blown away by the potential of it. And so, of course, I started digging into it and trying to understand how this new attention is everything idea works. looking at how the underlying models work and vectorization, etc. And became quite enamored with that as an idea, and started to sort of steer myself more and more towards that. As a senior manager, you tend to not be on the tools that much, and I found myself on the tools every night. Playing with it, understanding with it, using it for development, and as APIs and whatnot became available, building products with it. And so, I've been playing with it for 4 or 5 years, obviously following it along various other iterations of ML prior to that. But particularly in my last role for the last 12 months, running functionally a lab within NIB, doing experimentation and ultimately product delivery with AI. So it's been like everyone, a wild ride. Changes every 5 minutes. You have to be reading the news every 2 to keep up, and it's been a lot of fun, obviously.
Yeah, and as you said, we all got exposure to LLM-based AI around 4 years back. But in the last 1 year or so, I would say the AI engineering, that discipline has started becoming much more mature, right? And do you think we are at a stage in terms of maturity of AI-based engineering and coding that it is now becoming its own distinct discipline compared to traditional way of engineering?
Yes and no. So the concepts are the same, and so like I think if you were in an organization, humans make mistakes all the time, and we make coding mistakes all the time, and we're perfectly flawed people, all of us.
Yeah.
And if you're in a organization that has built good guardrails around human engineers, then you're probably already directionally correct towards having an organization that's reasonably well, or at least directionally set up for having agents also write code. Because good environments are environments that are intentionally low trust. So we have a good PR discipline, good CI/CD pipelines, ways of doing validations on data that's coming in and data that's going out. All of those are still required disciplines for an organization to have with AI. Typically, and this was a Atlassian study, engineers only spent 16% of their day doing actual coding. Right. So we're really optimized at the moment for that 16% where we're filling IDEs with characters. And that was never the job of engineering. The job of engineering has always been problem solving, architecting, and imagining new ways of solving problems. And so I think that as a discipline is still very much in play. And the optimizing around that 16% and the various other things that you need to build around that to make that safe and secure for deploying into an environment, it functionally exist, but they need to be scaled very differently because if you can imagine, if you've got 16% of an engineer's time, you've got an organization with 100, 1,000 engineers. And all of a sudden, that's through that same pipe, you're now shoving 10x of the code through. Obviously, your PRs are going to break, your QA processes are going to break, and you're shoving things into that pipeline through product managers, product owners, BAs, and at their back end as well, your cybersecurity and your cloud. They're going to start to strain under that. So you do need to think about how do we widen the whole pipe, but functionally, I think we've thought through these problems historically. We just need to figure out how to scale them in the same way we've scaled the code generation.
Yeah, I think it's wise to say we are building on top of all the fundamentals that we have built as part of the standard software engineering practices. But that 16% that you said that is unique potentially, that definitely I want to unpack in terms of what it means when it comes to the designing the reliable and predictable AI solutions, etc. But before we go there, this space is definitely is filled with many hypes, right? So I just wanted to pick up your thoughts on, at a high level, which of the trends you see are overhyped today in the AI engineering space, and more importantly, which trends have emerged but are underrated, which are not talked about that much, but should have get that much more attention.
Yeah. You go on LinkedIn and every man and his dog is on there saying, I built Spotify over the weekend.
Hmm.
And that is good for you, brother. I guarantee you didn't build Spotify over the weekend. You built something that was perhaps a nice clickable UI, and if you tried to launch that into production, you are gonna, you're gonna lose your customers' data, your own data, money, etc. So they built a nice POC, and AI is incredibly good at building POCs. Like just this morning, I've had an idea for a while that I've been going back and forth on. It's quite a complex problem space to solve in, and I thought I'll just start, start from the UI and work back towards the back end that I've started to build out. And I got a stunning, incredible demo, out of a PRD that I've spent months refining, but it's not a product. It is so far from a product. So there's definitely this hype because it's addictive, honestly. Like this, how fast you can spin something out that is functional, clickable, and can solve a real problem. And in some cases, that's enough. If you're solving a problem just for yourself, sometimes that's completely sufficient. But if you're going into a production environment, you need far more infrastructure around that process than I built Spotify over the weekend. And I think the other hype piece is that it's going to replace engineers in the next 3 months, 6 months. I don't believe that for a moment. I think eventually, over time, perhaps within the next 2 years, it will. I mean, it's already reshaping organizations and how they think about engineering and other disciplines within the organization. And over time, it will dramatically change. Like there's without a doubt the discipline, but not today probably. And enterprises are typically slower to adopt, and so that transition take a while. But the underhyped things, I think, are around the importance of harness and harness engineering, and it's something which people aren't talking about as much. Two things. One is multiplayer aspects of AI and AI use cases, where we, at the moment we've spent the last couple of years training agents how to work as a team, how to swarm over problems, and we've left humans out of that as this single player, through a chat interface. Whereas I think we need to broaden that out into a much more multiplayer mindset where we incorporate other parts of the organization, other parts of engineering to be able to influence the outcome. And people tend to talk about it as harness. I talk about it as meta harness or a harness because it's the things that outside of you as a personal developer working on something to start to include the whole team to be able to shape just the inference that's happening on your machine. So that's where I think we need to start moving towards a conversation of multiplayer and meta harness or harness. But certainly at an individual level, the harness is an incredibly important idea. I think a lot of organizations are stuck in the conversation around which model they're using, which is a very 2025 discussion. 2026 discussion needs to be around how we empowering people with better harnesses and empowering the whole org with the meta harness that we build.
Exactly. And that was, I wanted to unpack that anyway. So good you actually given the direction on that. If you had to take a deep dive, the first point I wanted to unpack with you was about how we ensure reliability of the AI systems in production. And as you rightly said, selecting model is just one fraction, one part of it. But that's not everything. The more important when it comes to reliability aspects in particular is how you ensure the security, how do you ensure the overall reliability of the system, and building that harness around that becomes incredibly important. And industry has shifted from the prompt engineering to now focusing more on harness engineering, right? So if would you mind unpacking that when you talked about harness, what really goes underneath? What are the key control planes organization should be thinking of to build a good harness?
Yeah, and uh, when people talk about harness, they're talking about multiple things, and so it's just it's a catch-all bucket at the moment. And I think we need to start to distinguish what we mean when we say harness, because the harness could be the various tools and memory types and things that you use in the native. It can be Claude code and Codex and Cursor are all examples of harnesses in their own right. But then when engineers start to talk about harness, they talk about the custom tooling they build, the sub agents that get called during invocation, and so there's that. There's those ideas, and then I've also seen people talking about harness in terms of the whole team infrastructure that sits around the single individual engineers. When I talk about harness, or I typically talk about a meta harness because I like to think in terms of whole teams. An individual is going to build the way they build, right? And some prefer VS Code or JetBrains historically. They pick their IDE. The engineers are going to build their own coding harness setup, and that's going to become their secret sauce, their magic. Like a Jedi building a lightsaber, and it's going to be unique to them. But the magic was never, if you look at Star Wars as an idea, we're enamored with the Jedi and their lightsabers, but that's just a tube with a crystal in it and some Force magic. And this is probably a bad example, but the Death Star. Now that is an architectural marvel. And it's what a stunning picture of civilization level collaboration. And so I think really the power going forward is going to be at that sort of meta scale where we start to think about harnesses or meta harnesses. So some of the things you mentioned, cybersecurity. There's obviously things like QA. There's cloud infrastructure, marketing has a say, legal, risk, compliance, they all have a say in how things get built. And models and coding agents are really good. I mean, really good. Right now, since December, and you had, what was it, Opus 4.7 come out around December. They've been astronomically good at generating code. And since, you've had various GPT models come out, and they're also exceptionally good. Now you've got Chinese models, GLM 5.2 and Kimi K 2.6, all very good at generating code. And so, like, personally, I've barely written a line of code in 12 months. I've written code, of course, but it's probably down on that 10% range. And when you're doing greenfields, that's totally fine. Like if I just put in a PRD or a prompt or something and have it generate some code, and I don't care that much around, style or language or infrastructure or databases, it's going to churn out something that feels like black magic. And that's, that's every man and his dog on LinkedIn who built Spotify. They're able to do that. But in terms of generating code particular to your organization, that's a completely different story. They don't know, the model doesn't know anything about your organization. And so this is where we need to shape a meta harness around it to shape the outcome together. that's unique to the needs of your organization. And so, one thing that I built was called the governor module, and that allowed actually two things that I'll reference. One was governor module, and that allowed vertical teams, so teams like cloud, cyber, data. Every engineer always screws data over because we make changes to the model that we don't tell them, so they're adjusting broken pipelines, etc. Risk, compliance, legal, marketing, they can all define their policies, and those get converted to policies as code and injected at invocation time into the coding agent, either via hook or MCP. Similarly, horizontal teams that are doing the actual code can define their particular teams, style guides, etc., and that gets injected at invocation time. And so now you have a control plane that sits over everyone's coding agents that is getting injected at invocation time, the various policies of various parts of the organization, and this is what I call giving agents good steer. The engineer can do good steer for sure, but when time crunch happens, they're probably not thinking about the 150-page documents that is sitting there in Confluence that define our cybersecurity mandates and how we do. And the agent definitely is thinking about that. But if we define policy as code and inject it at invocation, all of a sudden that shapes what gets delivered to be more organizational shaped. And that can, include things like how we deploy, what cloud infrastructure we prefer, how we like to secure APIs, etc. Then, and then since you have that policy as code, it's very easy to then reassert it at CI. And so you can virtually guarantee that what it needs to be the shape of code for your organization ends up getting delivered in a fairly similar shape to what you need for your organization, because you've worked collaboratively as a team, and if that changes over time, or each of those teams can own that vertical injection. The other piece is coding agents are very good at working on the individual code base that you are in. And so if you open up, a GitHub repo and it looks at it and it's able to reason over it, and that's great. The problem is organizations very rarely have a single code base. NIB had 3,600 plus repos. And you make a change in one of those repos, there's a high potential that there's going to be an upstream or downstream impact, to at least data or another consuming service. And so we need a way to give visibility to the coding agent for repos that sit outside the current thing you're working on, which you may not even know as an engineer you're making downstream impacts. Mm-hmm. And so something that I built, which I called Skynet, rather ominously, ingest all the repos into a knowledge graph, created vectorization, and extracted code intelligence, a code intelligence database out of that as well. And so gave the agents, the coding agents of the engineer, a 360-degree view of all the other repos that it could pre-calculate downstream impact and upstream consumption before it made a change. And so, neither of those are cheap things to build, and there are some examples of these, like SourceGraph has something like that for the Skynet example. But organizations need to start thinking about how they shape that meta harness to create good steer for the coding agents to make organizational shaped code, not just code in general.
Yeah. Clearly, you are a huge fan of Star Wars and Terminator, so we are definitely aligned there. Look, and I think one thing you said, and if I had to summarize, is in the traditional software engineering, most of those control planes, in a way, were more reactive, in the sense that you build a code, then someone will go through a security governance review. You will go through any other different types of reviews, but that's typically much more reactive. In the AI world, when you are talking about the 10x engineer workload, and the work is getting accelerated, you need to shift from reactive to more runtime controls, right? And that's where that harness becomes important, that it has to be more runtime than being reactive. But my question also is, given this is an emerging capability need, do you see industry solutions emerging as best of breed those runtime harnesses, or do you see organizations still need to build their own harness models?
Yeah, it's fragmented. So going back 12 months when I started the AI architect role, there just wasn't a lot of these solutions. You had to roll your own, and they fit into a category of what I call boring problems. And so doing PRs is a boring problem. Doing agentic PRs now is becoming increasingly a solved problem, because it's the clear next bottleneck after shipping, right? Is you're going to ship a large volume of code and it needs to be PR'd. And historically, those have been poor anyway, right? And we tend to, in engineering, rubber stamp stuff. Looks good to me, approve. Which is a bad way to do PRs, but it's probably how a lot of PRs happen in most companies anyway. And so the agentic PRs, and there's some debate about how best to do this, and should it be the same model as doing the invocation, and whatever. We can debate that till the cows come home. But at the velocity that we're going to see code getting shipped, that's 100% is going to need to be agentic. And so in some slices of the SDLC, we're starting to see these tools emerge, and I think that's great, and but companies are already starting to cry foul at the cost of tokens. These are just more token consuming machines, right? And so if we're not comfortable with the invocation tokens, we're probably not going to be comfortable with PR tokens, with the cyber tokens, with the QA tokens. And so I think we need to either get comfortable with the token spend, or figure out better ways to squash the cost of tokens, or get more comfortable using open source models and variable capable models. So throwing out some bits to say Haiku or Gemini 3.5 Flash for cheaper operations, rather than throw everything at Fable or and that's typically not handled that well in organizations. Everyone's throwing stuff out to supermodels as opposed to figuring out these nice thin slices.
Yeah. Let's shift our focus on the SDLC, the software delivery lifecycle approaches emerging in AI engineering. And when we started AI-based coding, as we started with just asking AI models, ChatGPT Codex or Claude, to build a small feature, complete a small task, and what Andrew Kapati at that time coined pipe coding, and that's the term that has stuck with us. But as we have matured the AI engineering practice, the shift has been around not just giving a task, but doing a proper spec-based development, spec-driven development, so that the AI doesn't do the coding just by intuition, but it has a very clear view on what is the requirements, what is the inputs, and how it should test the outputs, etc. And now we are also showing the shift towards more goal-driven development, right? Which is, you don't necessarily go and intervene AI at every stage, but you design a very clear goal, and then let AI iterate towards achieving that goal. How do you see these shifts emerging? And particularly, I want to get your thoughts on, when we talk about spec-driven development, what best practices are evolved there, and how spec-driven development and goal-driven development, which is now being taught more nowadays, how they're going to complement with each other.
Yeah, sure. So I before it had a name, I was doing spec-driven development. My first use of AI for coding was the copy and paste, like a lot of people, right? You ask a question, and basically using ChatGPT like Stack Overflow or something, it's spitting out an answer. You copy and paste that into your IDE and run. Obviously that was inefficient, and so companies like Cursor and Claude Code saw that single line complete, and kudos to GitHub Copilot. They were very early on this, and they were doing this single line completion, and that was great for what it was. Then the others thought, what if it could just complete more than one line? What if it could complete a whole file? What if it could reason over multiple files? And so Cursor and Claude Code come in and start to do that, and say do the copy and paste as well, larger chunks. Obviously, as you start to handle more or hand off more to the coding agent, it needs more context. And so, if you ask it, build me Spotify, it has a really great reference to go from. It understands what Spotify is. It understands the branding. You can probably go off and search it and find, the DOM and return you something that's pretty similar. In most cases, you're not going to be rebuilding Spotify. You're going to be building something particular to your organization, a feature that's particular to some functionality that exists in your software. And so its references are going to be, more limited. And so giving it, just like a human needs to have some framework around what it's building. This is what spec-driven development obviously gives it. And so some people see spec-driven development as just the PRD, where it's a definition of various pieces, and I find that a little bit loose nowadays. Whereas I like to use in that context, I like to use. Because I also like testing. I've been experimenting more and more with, say, Gherkin and Cucumber style practices, where you give it, smaller chunks, which ends up becoming tasks. But I also like to then go through and do an architectural piece and a solution design piece. And so I can get more granular in terms of the upfront steering of what's going to go into the coding agent. Now, and so, but I would consider spec to be, really clearly defined, thing that's going to be built. So a product requirements document with some breakdown of the end state, usage requirements, and what be basically good product practice. And then and incorporate some early injection of QA practice using things like Cucumber and Gherkin style language, and then move into the architecture. And so I'll have a separate architectural document where I define, it might be I get the original architecture of a piece and then extend that, and that gives me some assurance that it's going to land near where I want it to land. And then a solution design doc, similar to what I do. And honestly, the models are very good at generating almost all of that as well. So your spec, generate lots of it, review it, and at least you have reviewed. Anyone who's been doing spec-driven development for a while knows that the practice ends up becoming, okay, I give this to Claude. Claude, does, and I always do, a phased delivery. So give me, I want this to be a phased delivery, multiple tasks per phase, and it will split out those phases into tasks, and then quite happily tick through those tasks. What happened about 6 or 7 months ago, people started talking about loops, and there's obviously the Ralph Wiggum loop and others, things like Gastown, which automate large portions of this process. GSD is another one, and so what they found was, or what engineers were finding was that the model would go through, or Claude would go through as an example, and build task 1, task 2, task 3, and it's like, are you ready for task 4? And so their next action was yes, enter. And so their involvement in the development process and ended up saying yes and hitting enter. And hopefully they had some other, skills and things in there, or something in their Claude MD or what have you, that was steering the agent to also build tests and other things. And so, their involvement became less and less the better the models became. And so then you start to go, well, why bother hitting yes, enter at all? Why wouldn't we just loop through that and get, through full completion? Now, what I found with a lot of the sort of, particularly the early loop tests, and now there's some more defined golden loops. Earlier models would hit about a 70% good outcome. Now we're getting to more like probably an 80 to 85% good outcome, and you still need to do a lot of rework and testing, but most of it I find now at the end of the loop or at the end of a goal is I'm educating myself on what was built and getting it to replay to me and prove to me that what I've built was good. But these, I've had loops run for just hours, whole days, and at the end of it, I'm poorer because the token costs, but B, have just a huge corpus of code that now I have to try and understand. But functionally, more and more, and particularly with models like Fable and GPT 5.6, I'm seeing that there's code that is just very good, or outcomes that are very good.
Yeah, sorry. So the loop engineering is definitely becoming attractive, and there's a lot of uptake to that. But there are also a couple of concerns, and one you just mentioned is if not properly designed, it can lead to token maximization. That's one thing. And second thing is as AI keeps running into loops and the context keeps piling up, building up, the more context that is built, there is always a risk of drift. And so what are the best practices that are emerging, and what are the guardrails should be put in place in designing the loop so that these concerns are addressed?
Yeah. So one, this is a really simple one. A lot of people are already doing it. Is first of all, sub-agents, obviously, in your loops and how you define those, and so sub-agents will obviously get their own context, and so heavily relying on sub-agents, but then having I like to use a good model as like the orchestrator model that sits over the top. Something now Fable obviously is a good choice to define all of the tasks and define all of the what's ultimately going to get built. Hands off to smaller models like Sonnet. Sonnet 5 is very capable at generating code, particularly if it's going to be validated by a larger model like Opus or Sonnet. And in some cases, you can have even Haiku do things like documentation and whatnot, which are also by volume expensive exercises, right? And so writing tests or running tests or running the code and watching the output, Haiku is great for that. And so I think the cost savings, from a couple of ways. One is in organizations, this is a little bit harder because your cache pool is often smaller if you're running out of like an enterprise bedrock environment. But try to optimize for cache hits and that sort of thing, squashing your inference inputs and outputs with something like Tune or JSON reduction in some way. We've seen 30% plus reductions there. And so you can minimize the raw token burn, but then and the raw query burn cost you can definitely do by using sub agents that you clearly define and hand off a lot of tasks to smaller, cheaper models. But I typically like to have a larger model driving and then in post validation doing the code review.
Yeah. Look, the other point I wanted to unpack with you was around the testing and the evals for testing. Now, in the traditional software engineering and testing the traditional safety systems is all about You have clearly defined test cases, test criteria. You run those test cases after feature is built, and you either pass or fail. Essentially, the test case, right? That's not as binary in the AI and AI driven AI systems, right? How what are your recommendation in terms of building good test practice to support AI-based developments? What are the runtime evals which engineers should be thinking of?
Yeah, I think, out of the full SDLC, cyber used to be the one that worried me the most, because obviously, there's high risk there. But companies like Wiz and others have come in and they've built really great tool sets around that space, and there's continuing work happening there, and of course, big companies have seen the risk, and AWS is releasing stuff, Microsoft and Google and others. And so that's less of an unsolved problem. QA is, I think, the biggest sort of unsolved problem at the moment in the SDLC, Agentic SDLC. And I think it's a problem in two ways. One is we've always talked about QA shifting left. And the faster we move with agentic development, the less likely we are to actually shift the QA left, right? We actually, because the engineer can just run ahead, and they often don't talk to the QAs on the team around how this is going to be tested. What's being built, and often the engineer doesn't even know that, right? They might have an idea from the spec, but they don't know exactly the shape of it until it's built. And particularly in an environment where you're giving less steer up front. So I think, in terms of teams and enterprise teams, if there's ever a time for shift left for quality assurance, it's now. And so that needs to be quality assurance over the spec. It needs to be quality assurance over the sort of meta harness, and understanding how that's going to deliver what it delivers. But more and more, the job of a QA is going to be less around testing and more thinking like an engineer and acting like an engineer. And definitely at NIB, we were seeing the best QAs who were keeping pace with the AI engineers were the ones that were thinking and acting like engineers themselves, and building their own harnesses around what's getting built. Obviously, you got things like golden data sets to eval against, building, of course, most of the time models won't volunteer to build unit tests and integration tests, and so I think measuring the test volume of that, certainly, Playwright or other end-to-end testing frameworks and practices are increasingly important. And Anthropic has said multiple times, giving the agent the ability to test its own output is really important. And often engineers don't include that in their harness, and I think that's a real problem. Definitely involving the QA very early, and increasingly they're going to become engineers in of their own right, building their own. And this has always been true. There should be a tension between QA and engineers, right? It almost like the QA, their job should try and be to just fundamentally break anything the engineers build. And I think their ability to do that, they're becoming just so outgunned with both the pace and the visibility, that there's more and more they really are going to have to be engineers who deeply understand the spec, and are able to build frameworks at the same pace as the engineers are building code.
Yeah, cool. The other point I wanted to unpack with you, Adam, was around the context management and the memory, enterprise memory management. And as you and I know, that this is a unique thing about agentic systems, that they are more effective when the context is right. Right? That is not something that was relevant for traditional deterministic software. Now, the industry has evolved on that as well, in the sense that we started with designing the retrieval augmented model, applying retrieval augmented models to get the data, organizational context into the software, those systems. But now we are also seeing the emergence of large and availability of large context windows for these agents, right? Where do you sit in this debate whether RAG is more effective or large context models is the way to go, or there is something they need to complement with each other?
Yeah, I think it's actually a third option. So RAG is great if you want to understand, does something exist, in a document, but it doesn't give you why it's there. It doesn't give you who made a decision. And there's of course things like I think PRD become if the repo becomes the source of truth, PRD should be shipped with the repo, and that becomes something like the why a change was made. Now managing that over time becomes complex, right? Because in one way of doing it, I've seen people do is they just they update the PRD to match the code that's shipped, and so you have a record in the Git and in the Git history of changes over time. And why things exist where they exist. That's and then the other side is people store feature level PRDs, and so they have a history of change over time. But the context that really matters, and missing often from enterprises now that aren't using agentic delivery, and it exists usually only in the head of a couple of senior engineers, is why the code base looks the way it does. Why was change made 14 months ago that's now causing us this problem in production? I mean, you have to go and ask this guy that's been there for 15 years. The problem is these people leave, and so that knowledge leaves with them. And so I think there's an opportunity here with agentic delivery to start to think about this problem again as a harness problem, or as a meta harness problem, is capturing the intent, not just the change that we're going to make, but the intent, who made it, who made that decision, why that decision was made, the point in time when that became a deprecated idea, because like human memory, we learn new things and we degrade old memories over time. I think so. The third option, I think, is some combination of larger models for sure. But I think that's going to threshold, and you see that already, like in a in a million token context window, you're really only getting sort of 500,000 tokens worth of useful memory there, and after that it starts to degrade quite a lot. In fact, it starts to degrade after about a quarter of the way through. You start to see it slip a bit. And so I think we need to refine what gets passed in. RAG does that in part, but as I said, it doesn't give you any of the why, or any of the when, or any of the the decision ledger or change in decision over time. So I think we actually need to have some combination of RAG and graph, where the graph is the nodes are keeping track of decisions over time. And the specific parts of because you RAG a document, or RAG memories, and you're going to return just tons of results, and those may or may not be the context that you want, and so then you're again throwing that into the model to decide. Whereas a graph is going to be a little bit more deterministic around the choices that are made, and so you're starting to see companies like MemZero and others enter into this space where they're building graph-backed memory systems, and I think more and more this is going to become something which organizations want and need. Not only are they going to have their business context, but they're going to have this code context, where we're going to be capturing the episodic memories out of every coding agent, and starting to store that in some way and referenceable through a graph so that my coding agent has the same context as your coding agent to the changes that were made over time. Obviously, that's not really in place yet. You make a change in the code, it exists in your context, and I don't have it. And as soon as you start a new context, it's lost forever, right? And so we don't have any history of the decisions that were made. We don't have any, why that decision was made, who made that decision. And these are actually really important for organizations to have, not just for, for reason for blame, which we, humanistically we like to do, but for reasons of context, particularly as we get to, which we haven't even spoken about yet, which is, regulatory and compliance problems, particularly in the FSI space. Where has the human been in this process? Who drove these decisions? Why is the code shaped this way? And so we're left being archaeologists of code without really having a map to be able to go through the history of the changes. And so I think, graph-back memory, where we start to record sort of that episodic movement of invocation through coding agents and agents running in the cloud, et cetera, is going to become more and more important over time. I think it's a combination of both, but a third thing, which I think is being able to actually point and time stamp it with the decision and who made the decision.
Yeah. And as organizations are at the early stage of designing and building these context planes and enterprise memory layers, and you mentioned episodic is one of the layers, etc. But I see as organizations start building more and more agentic systems, they will have to start considering about how to optimize the context, for example, because how to cache memory, because if different agentic workflows may require different context, and just enough context, that is also important, because too much of context may also drift the agent. So how do you see that those emerging concerns may not be the concerns today for organizations because that's so early stage, but as they start maturing, these will become real concerns for them, and how they should be thinking of addressing?
Yeah, definitely. I already think a lot of engineers, just as an individual level, overstuff their coding agents, and I think there's always a danger that people want to overstuff their cloud workflows as well, like the agents running Bedrock, etc. The reality is, the reason it's not a problem for a lot of organizations right now is that their data in general isn't ready. Like, there's still a lot of people haven't made the full migration across of their data into a cloud environment, or figured out how to expose that to agents. But as they do that, that's obviously going to become a problem. The problem now is the agents probably don't have access to enough context to be able to give meaningful answer. In 6 to 12 months time for a lot of organizations, and there's already some in this spot, they're not going to they're going to be having so much context that the agent basically becomes useless because it's getting too many hits, or they're filling the context window, or they can't use cheaper models, which typically have a smaller context. So I think being able to thin slice that, and again, I think Graph helps with this, because it rather than RAG or just randomly stuffing in every bit of context into a system, the knowledge graphs allow you to thin slice the information that you're putting in through more refined and targeted queries. So I think knowledge graphs are going to become more and more important for organizations, or ways of smart indexing. I know Snowflake has some of these solutions, and Databricks as well have these. And so ways of fast discovery of just the right information just in time and injecting that in is going to become really important. And as you mentioned, cache is going to become more and more of an important concept for organizations, which perhaps haven't had to think about it before, because that's a cheap and fast retrieval. So I think there's a lot of space for companies are thinking horizontal to scale. and build it wider, build it deeper. Whereas I think the cost is going to become just prohibitive, and so they're going to have to start to think, build it smarter. We're in that early stage where throwing money at a problem solves it. Eventually, that starts a threshold, and you're going to have to start throwing intelligence at it, right? And smart problem solving. So yeah, I think we're getting, some companies are already there, others are starting to get there, and more, we're in this sort of, this pyramid phase where we've got a handful of companies that are actually ready for that.
Yeah.
But 12 months time, it's going to be every consultants are going to be off their feet solving these problems.
Yeah, hopefully. Look, as we start wrapping up, Adam, I do want to close on the governance aspect of AI. You alluded to that already, and the level of governance varies on AI when you look at more regulated industries versus more technology digital businesses. I also, like you, I also come from health insurance background, so I know the rigor of governance that is required in those industries. But the early stages of AI governance, which very much modeled on typical traditional governance models, where you will have a governance forum where the new AI opportunities will be discussed, the ethical aspects will be discussed, etc. But I think I'm pretty sure you will agree that we need to now start thinking of the broader definition of governance for AI. When it's all about not only the ethical aspect, but the cost, observability aspects, etc., the FinOps aspect, also what needs to be more real time versus what could be reactive, right? So how do you see the overall discipline of AI governance emerging or should emerge in the future?
Yeah, look, one of the things I really enjoyed, it's a funny thing to say, I enjoyed governance, but I'm a move fast and break things sort of person. I like to see if I like to ask, can I rather than should I? And that doesn't really go that well in a heavily regulated insurance space. And so well before I got into the role of AI architect, they'd already started to put in the governance stream. And so that really gave me an operating model and framework to play within, which was fantastic. And it sort of predefined a lot of the structures that I had to build. And I think a lot of companies, their appetite is going to be to jump straight into building solutions rather than, first of all, wrestling with some of the ethical and some of the, and some of the regulatory things that they really need to cover off first. And what they'll find is that'll become just a massive break, like a massive break pump for them, unless they sort that out first. Because we're playing with people's data. We're playing, in the health insurance space. Like, you lose someone's, license details or credit card information, you can issue them a new license, you can issue them a new credit card. You can't issue them a new health history. Yeah. And so ensuring that there's security around, and this is something that NIB was fantastic at. Their cyber team was just very good, very diligent, and it gave me some assurance as I was building that was well-governed data. And if you really want to give, and this was a real hesitation within engineers and adoption in general, if they don't have a confidence that the end systems are going to prevent them from making horrible mistakes, they're not going to adopt it. Because engineers are smart, right? They're some of the smartest people in organizations, and they also want to do good. They want to build good things. They want to build good products. They don't want to hurt the end customer. And so if there's any sniff of that, they'll be resistant to adopt. And so companies who really want to see AI adoption and their engineers pick it up and prevailing in their teams and building these amazing workloads and agents in production, they really have to think about governance as the a priori first thing they jump into, or their engineers are just going to be so anxious around, the potential negative externalities of what they're building, that they just won't do it. And that'll be the common thread of objection will be, can you guarantee me that this, I'll build this and ship it. Can you guarantee me that, that this will protect the end user through the guardrails that we built on the surrounds of this deployment? And you have to be able to answer yes to that. Otherwise, the engineers they won't. And so some of those guardrails need to be shifted left. I spoke about governor module, where you're injecting certain governance pieces at invocation time, asserting them on CI, but absolutely on the back end of the governance, making sure you know every run of every agent, what it did, what its output was that compared against the gold standard? Was every action logged? Was every tool call logged? Is someone reviewing that or agentically reviewing that at least? Like these are, shipping something to production, building a prototype, it can be 90% good. And that's good enough. You have multiple agents, typically in any system. Now that compounds, and that compounding debt is now, but by the time you get to production, now it's only 59% efficient. Each one 90%. And so wouldn't you ship something that you were, 59% sure wouldn't leak data? No, of course you would, right? We need better. We need to be thinking as organizations around these guardrails, not to get everything to 100%. But have we built a system overall, and this is for humans or for agents, that can give some assertion and some guarantee that we're not going to do wrong by our customers? And I think that's way more important to think of if an organization is thinking of adopting AI, both for their human engineers and the agentic engineers, before they even turn on a Claude license. Does our system inherently protect the outcomes of our customers? And if they can't answer absolutely, then they should probably stop shipping code now and fix that. Let alone shipping Agentic.
Yeah. On that note, Adam, thanks for your time. I think this was really a wonderful conversation. We covered many topics under AI engineering, and people who are real interested, who are think in the middle of building the AI engineering practices, or even in general think of how to embed AI into their organizations. I think there are many takeaways for them. So thanks again. Thanks for your time. Pleasure hosting you. If you found this discussion valuable, please follow and subscribe to Enterprise Tech Talk. And thanks for listening. I look forward to seeing you in the next episode.